Hi everybody. In this video I'm going to start doing electronics and wiring and that sort of stuff. And this is the first thing I've started assembling with regards to that. These are the fuse holders for the high voltage auxiliary equipment. I've got 4 of them and they each accept a cartridge fuse in there. I've mounted them to basically just a little piece of DIN rail, and those will sit here in the box. This is where the main high voltage feed comes into this box, and it's the first thing that it goes into from the battery. So this contactor will act as the main contactor and will switch the high voltage on and off to basically everything. Then there's this short piece of copper bus bar. This is the motor contactor. So what this will do is turn power on and off to the motor while leaving the other stuff like the charger, DC-DC converter, and AC compressor and heater engaged. This is a pre-charge circuit where in order to actually energize the motor, you first have to charge up the line capacitors inside it, because if you don't, you'll have a very high current when you first close this contactor, and that will probably weld some things shut or blow fuses or break your very expensive motor inverter. So this has some high voltage resistors inside that allow the motor capacitors to slowly charge up. And what you do is you connect these terminals across these 2 terminals on the contactor. It's got a little MOSFET inside that allows the current to start flowing slowly. And then once it detects that those capacitors are charged up, it will energize the motor contactor coil. And all you do to control this is just put 12 volts on it when you want it to start up. I figured it's about time I try to do the first crimp onto this big 4/0 cable. The first problem I realized was that I didn't actually have a good way to strip this cable. So I looked around online a bit and found someone suggest making basically this. Needs to be a little bit deeper. There we go. It worked all right. Huh. I didn't know there was fiber reinforcement. That's odd. That's tough stuff. Okay, I'm gonna go get the hydraulic crimper. So here I have the hydraulic crimper with the largest die in it. So I'll see if I can get this going. Okay. All right, the jaw is definitely closed. So let's see how we did. Okay. I probably need to do a second one higher up. So I thought I saw this thing move a little bit, and it's definitely not supposed to. So I'm going to employ a very sophisticated testing method to make sure that this is absolutely solid. It's clamped into the vise, so I'm basically just going to really pull on it. Oh. Ah, that's not supposed to happen. Wait a minute. Uh-oh. Where'd all that wire come from? I'm gonna have to watch that back. So I looked really close, and you can kind of see there's that strand outside, and that like fell out as I was trying to get this on there, and since it was only the one, I cut it off. But it's still like exactly where it was. So I think I might have somehow pulled the cable like out of the jacket or something, despite it being clamped in on the vise. So the crimp, I guess, is good. You're not supposed to be able to move those at all with just your own weight, like hundreds of pounds or something, even for 2/0. So I got to figure out how to get this cable back inside the jacket. So I, for now, fixed this switch in here with this little aluminum bracket that's just screwed into the floor. It's a little wobbly, but it's good enough. And this is the manual battery cutoff switch that breaks this pack in the back here into the top three cells and then the bottom cell of the pack. And then I've taken that crimped connector that I just made and put it on there, so that way I can figure out how long to cut this cable to go around the back and hook up to the battery. Alright, this wing is going to be the death of me because I just smacked my head into it again, and that kind of hurts. But battery-wise, so here's the terminal I need to get this wire to, and I've kind of coiled it around, and I think about that much cable will be enough. So now I gotta cut it, which makes me a little nervous because it's like $9 a foot. Well, it's cut everything else, so why not the cable? It's dirty, but I can probably I can probably clean that up. I've got a bit of a problem with these terminals, which is that these wire lugs don't fit on there like that. So they're very wide relative to how big the battery terminals are. So I figure I can cut that off and do this. So having them stick out like that isn't great, but I can bend that kind of down like that. And then while it's tight, because I'm up against the floor here, I think this radius can be made to work. So I'm going to try crimping this on there kind of like that and see if that makes that connection. Alright, so I didn't like the way it was bent all around like that, so I decided to try trimming off the side of another connector, and it seemed okay, so I did that to this connector, where you can kind of see I cut an angle off there, and that allows it to fit more or less to the side. And since there's that slope down there, it can then bend down that slope, and that lets the bend radius be a little larger. Now it does kind of get in the way of this one, but I think I can deal with that by pushing it off a little bit to the side or having it go the other way or anything like that. So here you can see that I've got the large cable pulled up from the back, and this cable has to connect to here, which is the positive side of this battery pack, and it'll connect to the negative side of the rear one. So to do that, I've got this bus bar that'll extend over from the battery post back so that this cable can come straight up into it, and it'll go through the side of whatever aluminum box protects these batteries from the elements. There's a couple small problems with this. The main one being that there's this little bit of metal here that this could lever down on, and that would break the isolation of the battery pack. So to fix that, I've got a relatively small grinding wheel, and I'm going to try to take that down until it's just the plastic. Alright, that's pretty flat. So that'll allow me to put this in with less risk of it breaking through the insulation and touching that. Obviously the cables aren't going to hold themselves into the car, so I need a set of cable holders to keep them in place underneath. So what I've built here is 2 blocks of plastic, cut them to the same length. Then I drilled these holes, which are the same spacing as some rivet nuts that are in the bottom of the car that held on some parts of the exhaust. And I clamped these together with the bolts, drilled some big holes through there, and now by clamping these bolts together, I can clamp this cable down and hold it in place, and also hold it to the bottom of the car. And then there's a hole for a second cable here. There's no bolt over here, unfortunately, and I had to shim these up a little bit because I made the hole too big. Just a little bit of electrical tape, but it holds pretty good. I don't have any 10mm bolts right now, so tomorrow I'm going to have to put those under the car after a trip to Ace. So I went ahead and made the rest of the mounts and bolted them to the car. This cable goes all the way from back here, where the negative side goes into the car, there to a junction box, and the positive side goes into there, which then goes into one of the rear batteries. And then these travel all the way back up to the front. Where they curve off and go up to the front battery pack. Here's where those cables come up. For now, there's not really much protecting them from the bottom, but eventually I'll fabricate a plate that goes underneath to protect those cables and whatever else goes through that tunnel. So this cable comes up here, and there's a bus bar that jumps from that terminal over to there. And you can see there's another mount thing there holding it in place. And then this other cable I haven't cut yet, because this needs to go into the fuse, which is right here. And the fuse, I think I'm going to do basically this. So I put these cross beams on top of the battery pack to hold the batteries in up and down, and that'll help keep them from flopping forward and back. So I think what I'm going to do is I'm just going to bolt this fuse to the top of the battery pack and then run like a bus bar out to here and then connect that cable up kind of like that with a bus bar, like this. And then there will be another bus bar that goes down and onto that battery terminal there. To protect these copper bus bars from moisture that would cause corrosion around the connections potentially, I'm electroplating them with tin. So how this works is I've got this cell here. In the cell, I added 50 milliliters of hydrochloric acid, dissolved a piece of tin in there for a few hours. That's what's left of it. And now I've got a positive tin electrode and a negative copper electrode. And you can kind of see that this copper electrode is no longer copper colored, but tin colored. So we're putting 1.5 amps through there right now. And in a little while, I'll take it out, flip it over, run it for a few more minutes to make sure it's nice and even. And then I'll move on to this other one, and then I got a third bus bar to plate. I would have time-lapsed this, but it actually happened like right away when I switched on the current, changing appearance. So all that happens now is it just bubbles and that coating gets thicker. So I am having some problems with these dendrites forming, and like the power supply is getting unhappy, and like weird oscillations are happening there. And it probably doesn't help the plating be like even and stuff. All I've really been able to do about it so far is clean it up. I'll probably try running at lower currents just to see if that keeps it from getting all crazy like this. So I cleaned that off, and the power supply is still kind of upset, even after turning the current down to like a third of what it was when we started. So I guess I'll give it some time and see what happens. Well, it seems like there's not much I can do to stop the dendrites from forming, so maybe I'm just at the max thickness this will support or something like that. So I'm going to cut it off there and clean it up a bit and be done with this piece. Alright, I've loaded up another part. We're going to start at a lower current setting, so let's go. And that's it. You can see it's already changed color pretty dramatically. Well, maybe not on the camera, but it's pretty obvious that it's got tin on it. Now just wait for the plating to get thick. Alright, so I've made a bit of a change. Basically, I just set this fan on the table and put it on high. What that does is that shakes the speaker a tiny little bit. You can kind of see the water shimmering around, and hopefully that'll help keep the bubbles clear of stuff. And also keep my power supply nice and cool. So going slow wasn't really working out very well, so I decided, what if we try going fast, because maybe the bubbles will just push the other bubbles off, and that seems to be what's happening. There are some stuck on the bottom and some on the top, but they do get pushed off occasionally. And of course the fan shaking the crap out of everything helps too. So I'm running it at 2 amps now instead of 0.3, and maybe that'll actually get it plated, especially considering that there might be a storm approaching and I gotta put all this away before then. So I'll give it some minutes and see what comes out. I had to stop early for the rain, but that piece seems pretty well plated. I scuffed it a little with the pad just to clean it up, and it looks good to me. So now I can use that to connect together some of the contactors. And I've got one more piece to do, but I'll have to do that tomorrow when there's not rain. And there's that last cut in this cable. And that is all I have left, so I think I did a pretty good job guessing how much I need. There's just a tiny fraction of an inch of insulation left that I gotta cut. That's pretty easy to do. Glad that was the best one yet, probably, because that's the last one. Alright, so here's the last of the 4-aught wiring installed. So there's a few things that aren't done with regard to the main traction power loop. For a start, I need to put heat shrink on these joints. There's a couple nuts that I'm missing that just weren't there on the batteries for some reason. I gotta get some nice ones for those. And the biggest item is that there are no bus bars connecting the adjacent batteries. So I need one there. I need one from there to that terminal down in there, which is going to be a little tricky because obviously it's got to be like a Z shape. And then I need the same adjacent battery ones up front. But that's kind of been why I haven't been wearing gloves or worrying a whole lot, because the voltages available right now are pretty low, and they're only on those terminals, which are pretty well separated. Every day or so I test the isolation of the batteries just by probing around with a multimeter checking for residual voltage, and all of these sag down from a couple volts down to like half a volt when you put the meter on there, so the isolation is tens of mega ohms or better depending on what the multimeter I have does as far as input impedance. I've also got a little bit of progress assembling this contactor box. I don't have the pre-charger in there, but I do have some of the auxiliary fuses, which are going to be more up here, and a couple of the wires going to them. Unfortunately, I didn't leave space behind some of these holes for a nut, so I've got to use just these middle two here where I can get a nut behind there. And you can see that the wire that goes to the motor is hooked up. Same thing up there at the negative terminal. Up here, I've secured this fuse onto these cross braces and these cross braces onto the mounting structure. And this is held down with some M6 bolts in that plastic fuse holder thing. And then a bus bar runs through what'll be the side of the battery protection box and hooks up to the wire that goes then back to the negative terminal inside the car. And over here is the intermediate positive terminal from the front battery pack. You'll notice I don't have the bus bars installed on there, just to keep more things disconnected and reduce the potential for there being like a short to a tool or something weird like that. But with all the big wiring installed and it being a Sunday, I'm going to call this video there and start thinking about how I'm going to get to the point where I can do a power test. The power test just being applying the high voltage to the motor, as well as getting the CAN bus hooked up to like a laptop and stuff so I can make sure that it's working, gas pedal, gear selector, stuff like that. So in terms of what work there is to do to get to that point, I need to do these intermediate bus bars between the batteries, of which there's like 5 or 6. I also need to get at least the big parts of a 12-volt power system in place. So I'll buy a nice AGM 12-volt battery, smaller than a car battery since it doesn't need to crank an engine, it just needs to run the computers and stuff. And I have the 12-volt down converter for keeping it charged up when I'm driving. But I'll need something to power up the control systems in the motor. I'll need to run the control harness from the motor up into the car into the control box. And I'll need to at least temporarily hook up the gas pedal and gear select switches to the motor. And once I do that, I will also need to put the transmission fluid in the motor gearbox just to make sure I don't screw anything up while spinning the wheels. And once that's all done, I should be good for just spinning the wheels here in the shop. So look forward to that. I'll see you next time.